This is Andrea Hendricks. The objective of this video is to use long division to divide polynomials by a binomial. If you recall, polynomials just represent real numbers. When we plug in a value of x that's in the real numbers, we will get a real number output, right? The domain of the polynomial function is all real numbers. The range is not all reals, depending on if it's an even degree polynomial function, but the idea is that the output of that polynomial function is a real number. So with real numbers we can perform all kinds of operations on those, so that means we can perform operations on polynomials, and you most likely know that. One of those operations is division. And why do we need division? Well, this goes back to a theorem that we talked about before, that if x equals a is a zero of a polynomial function f of x, then we know that x minus a is a factor of that polynomial. Well, do you remember what it means to be a factor? Let's go back to just simple numbers for a minute. Let's say we know that we have the number 24. Well, we know 6 is a factor of 24 because 24 is equal to 6 times 4. Right, we can write 24 as a product of 6 and another number. Another way to think about it is that 24 is evenly divisible by 6, right? Well, we're going to use those concepts to extend to polynomials, because if we know that x minus a is a factor of f of x, then f of x is equal to that binomial x minus a times some remaining polynomial. And the polynomial q of x is a polynomial of degree n minus 1. So in other words, the expression x minus a divides evenly into f of x with no remainder. So let me show you. Do you remember dealing with a polynomial like this, x squared minus x minus 6? And way back when you learned to factor that, so did you remember that that factors as x minus 3 times x plus 2? Well, that means that x minus 3 and x plus 2 are factors of x squared minus x minus 6. So it should be that if we divide this polynomial x squared minus x minus 6 by x minus 3, we're going to get actually x plus 2, but we'll show that there is no remainder. So let me show you how to do the long division here. So if we want to divide x squared minus x minus 6 and we're going to divide that by x minus 3. Well, division of polynomials is just like division with real numbers. We want to take this x and divide into x squared. So we know x goes into x squared x times. And what do you do with that? Well, then you multiply, right? So x times x is x squared. X times minus 3 is minus 3x. Well, then do you remember in long division you have to subtract. So if we subtract, that really distributes over to this resulting binomial, and then we'll change the signs, right? So that becomes really a minus, and this is a plus. So we have x squared minus x squared cancels. This is really negative x plus 3x, which would be 2x, and then we bring down. Well, now we have to say x goes into 2x. X divides into 2x plus 2 times. 2 times x is 2x, and 2 times negative 3 is negative 6. So now when we subtract, that again we'll change all the signs, so that's going to be a minus 2x and really a plus 6. But notice that 2x subtracts to 0, negative 6 plus 6, that is 0. So we find that there's no remainder when we divide x squared minus x minus 6 by x minus 3. So just as we knew, we proved here that x squared minus x minus 6 is indeed equal to x squared, I'm sorry, not x squared, x minus 3 times x plus 2. Okay? Well, let me show you that with another example. Let's suppose we want to divide 5x squared minus 17x minus 12 by x minus 4. Okay, so where would we start? So we have to say x goes into 5x squared, 5x times. Now multiply. 5x times x is 5x squared. 5x times negative 4 is negative 20x. Now we're going to subtract, but don't forget that when you subtract this, the negative sign will distribute through, and so that's really going to be a negative, and then that will change that to a plus. So 5x squared minus 5x squared, that's eliminated. Negative 17x plus 20x is a 3x. Now we bring down the minus 12. Now we say x goes into 3x 3 times. So 3 times x is 3x. 3 times minus 4 is minus 12. So when we subtract, the signs will change, and what will we get as our remainder? 0. Right, so that tells us right there that 5x squared minus 17x minus 12 is equal to x minus 4 times 5x plus 3. Okay? Let's do one more example. Let's say we want to divide 7x cubed plus 3 by 2x plus 1. I'm sorry, by x plus 2. Let me change that. Okay. Whenever we divide polynomials, a key thing about that is that they do need to be in standard form, that is with the highest power first and in descending order, and then you also need to have every variable represented. So if it's not represented, we imagine it to have a 0 coefficient. So we could rewrite this problem as x plus 2 divided into, we would write it as 7x cubed plus 0x squared plus 0x plus 3. Okay? And now we can divide. X goes into 7x cubed, a 7x squared. Now we multiply. 7x squared times x is 7x cubed. 7x squared times 2 is plus 14x squared. And now we do what? Subtract. So when we subtract, the signs change. I'm just going to write it like this. 7x cubed is eliminated. 0x squared minus 14x squared is a minus 14x squared. And then we bring down the next term, which is plus 0x. Now we divide x into negative 14x squared. So x into negative 14x squared is a minus 14x. Negative 14x times x is negative 14x squared. Negative 14x times 2 is a negative 28x. Okay. Now we subtract, which is going to change the signs. So we have the 14x squared is eliminated. This would leave us with 0x plus 28x, which is 28x, and then we bring down plus 3. So now we say x goes into 28x plus 28 times. So 28 times x is 28x. 28 times 2 is plus 56. So now we need to subtract, change the signs. So the 28x's are eliminated. 3 minus 56 is a negative 53. Now we are done dividing because x does not go into negative 53. So this shows that x plus 2 is not a factor of 7x cubed plus. So this tells us that we can rewrite 7x cubed plus 3 with this information that we just found. That is 7x cubed plus 3 is equal to x plus 2, which is the divisor, times 7x squared minus 14x plus 28, which is a quotient, plus the remainder, which is minus 53. Or you could say that 7x cubed plus 3 over x plus 2 is equal to 7x squared minus 14x plus 28 minus 53 over x plus 2. Okay? This first way of writing it is called the division algorithm. So it basically says that we can rewrite our polynomial function, which is our dividend, as a divisor times a quotient plus the remainder. So this is the divisor times a quotient plus the remainder. Okay, and this is called the dividend. Okay, so if you have any questions on long division of polynomials, please don't hesitate to contact me.